Okay, so now we're looking at example 3. Calculate the slope for a given equation. So this is the equation they're giving us. They're telling us it's a line. I know it's a line because it's in the form y equals mx plus b. Let's reach ahead a little bit here. What's the m value? Winston, what's the m value of this thing? Not 3. Close though. You got it. And that's important, okay? Because a negative slope does something to the line. A negative slope is going to change your line in a very important way. So, that's our slope. And I would even say we should talk about it as being negative 3 over 1, which means I have a line here that has a slope of over 1, so that's your run, down 3. Ah, that's very different, isn't it? So you've got your run of 1, and your rise is actually negative. So we're going to go down 3. Let's take a look if we complete the table. So they gave us numbers here. So those are the numbers that we're going to plug into negative 3x plus 2. So it's going to be negative 3, negative 2 plus 2. It's going to be negative 3, negative 1 plus 2. It's going to be negative 3, 0 plus 2. It's going to be negative 3, 1 plus 2. It's going to be negative 3, 2 plus 2. We're going to work all of those out. Negative 3 and negative 2. You've got to get this right. Use a calculator if you need to, but use your calculator right too. So it's the way I would do it if I were you is I would do 3 times 2 is 6. Negative times negative is positive. I would do it in 2 steps. So that's positive 6 plus 2 is 8. 3 times 1 is 3. Negative times negative is positive, plus 2 is 5. I would take my time doing this. I wouldn't rush it. Because if you get one wrong, your line's not going to be a line. Negative 3 times 0 is 0, plus 2 is 2. Negative 3 plus 1 is negative 3, plus 2 is negative 1. Negative 3 plus 2 is negative 6, plus 2 is negative 5. Once again, I think it was kind of important if we put in an extra column here. Yeah? It's negative 4. It is. I made a mistake. Good catch, Mr. Giles. Thank you. Change that to negative 4. All right, over here. So we've got x comma y. So what's going to go in? Our x value is negative 2, comma 8. Our x value is negative 1, comma 5. Our x value is 0, comma 2. Our x value is 1, negative 1, 2, comma, negative 4. So those are all my points that I'm going to plot. Now, let's think about this for a minute. If I look on the left-hand side, what's the difference between negative 2 and negative 1? It's plus 1, isn't it? What's the difference between negative 1 and 0? Plus 1. Plus 1. Plus 1. So the differences, what we call the differences here, are going up by plus 1. What are the differences in the y's? What's the difference between going from 8 to 5? Now to do the difference, remember what you have to do. You've got to do 5 subtract 8. So that's actually going down negative 3, isn't it? And what's the difference between 2 and 5? Well, that's subtraction. So 2 minus 5 is negative 3. Negative 1 subtract 2 is negative 3. Negative 4 subtract negative 1. Negative and negative is positive. So it's going to be negative 4 plus 1 is negative 3. That's your slope. All of them are constant. That gives you a line. So let's graph the line. Let's put these points on it. Negative 2 and 8. Negative 2 and 8 is here. Negative 1 and 5. 0 and 2. 1 and negative 1. Do I really need to plot all of the points? No. You actually only need 2 points to get a straight line. But if you want it to be accurate, you should do at least 3. Okay? Otherwise, you have a possibility of not quite making it accurate because of human error. So here's my line. that line represents all the points that work with y equals negative 3x plus 2. That's what that line represents. It represents every single point. Notice, I did a chart with only 5 points. 1, 2, 3, 4, 5. I only did 5 points. But the fact that I've connected it meant that I could have picked any x value at all, right? I could have picked x values larger, and it would have had a place on the line. So I could have picked 4, and it would have come down and had a place on the line. I could have picked a half, and it has a place on the line. I could have picked negative a half, and it has a place on the line. So what I really want you to start to understand is that a line is actually an infinite number of points all being put on together. And when we draw a line, what we're actually doing is representing all those points. And since there's always a point in between every 2 points, we just draw it as a line, meaning everything's there. All right, we'll pause the video there and we'll come back in a minute. Oh, before we do that, let's look at the rate triangle here. Let's say I took a point. Let's say I started here, and let's look at my rise over run. So there's my run. If I go over 1, I got to go down 3. So notice that's 1, negative 3. So if you think of slope as rise over run, what you have is negative 3 over 1. There you go. That's pretty cool. What if I went in between this point and, I don't know, do I have another good point? Here's another good point. It was 0. Yep, 0, 2 is on there. So I go over 2. How far down should I go? If I go over 2, 1, 2, I should go down 6. Because the ratio still has to be negative 3 over 1. So this would have been slope equals negative 6 over 2, negative 3 over 1. It reduces. And that's why we have to be able to reduce fractions. Okay, we'll stop there.